Hello everybody and welcome to my new YouTube channel Sea Ice Stories. I am a sea ice physicist working in the polar regions of our planet, and I would like to explain you a little bit more about how my research work and what we are doing and why we are doing it, so that you can get to know a little bit about my work. So what we want to do today in our episode is we want to look at how we drill holes in the ice. So there's different ways that we are drilling holes in the ice. It's a thing that I'm doing very often because you can imagine if you want to investigate the ice, you either need to get under it or you want to get some samples. So have fun watching this episode, and now we explain you how we make some holes in the ice. Okay, so the first question that you might ask: why are we actually at all drilling holes in the ice? It's a very easy thing. If you're just standing on a slab of sea ice and you want to know how thick it is, for example, then you need to drill a hole through it, put some type of tape measure under it, and then you can determine how thick it is. Also, if you want to get any ice sample, or if you want to deploy any equipment under the ice, you need to drill a hole through the ice to deploy your equipment through. So it's very important that you can drill holes, and it's a skill that every sea ice physicist has to develop throughout his career. And there's a lot of variation in how we can drill holes. So there's small holes, there's large holes. You can drill in thin ice, you can drill in thick ice. So there's a lot of variability, and I want to go a little bit about how we drill holes. Okay, so what different kind of drill machines are we using? So we have two big different groups of drills that we are using. We're on the one hand side using drills that we call augers, ice augers, that look fairly much like a drill that you use in your normal drilling machine, just a lot bigger and capable of cutting ice. They really cut nicely and efficiently quick holes of various diameters. We can use the 2-inch auger, which makes a 5-centimeter hole, or it can also have very big augers that make holes of this size. So they are very efficient and make nice holes. Problem is, well, if you want to get any ice samples out of that doesn't really work, because as you know, when you drill in the hole in the wall, you just get all cuttings small out of the wall and nothing yet you can really analyze. So if we want to get samples, we have the big different kind of drills, and that is the so-called ice coras. They produce an ice core. So you're drilling into the ice, and actually in the middle you're retaining a column of ice, and you can retrieve that afterwards and analyze these ice samples. So this ice coring is very important for a lot of different research. We use it a lot on sea ice to get sea ice cores, but we also, you may know it, for example, it is used in drilling ice cores on glaciers or ice shelves. On sea ice we're mostly dealing with rather thin ice, so typically in the Arctic we now have to deal with ice thicknesses around 1 meter or 2 meters. Then it's a very easy process taking a core. But if we end up working on multi-year ice, which we have been doing last year in spring as well, and you have to core a hole through 6 meters of ice, or even just drill a thin auger hole, that is very interesting and quite a workout. So what kind of drill machines are we using to drill those holes? So there's always one machine that is just your force. All those different kinds of augers, coras, they all come with a hand crank, so you can just basically turn the core by hand, or the auger by hand. The problem is, if you want to drill a lot of holes, that gets very, very exhausting very fast. So usually we try to attach a motor drill to that. Usually this is a normal, very powerful battery driven drill engine, mostly some normal as you know it from the workshop. But if we drill deeper holes, or especially for ice coring, we like to use fuel-driven drills. So that is basically like a little chainsaw, just that it doesn't cut trees, but we can drill holes with it, and then we attach the corer to this little motor and can drill. They are very powerful. You can easily drill, well, not easily, but you can drill 5 to 6 meters sea ice with a little bit of effort, but they are very powerful, so you also have to be a bit careful in handling them. So the most important drill operations that we are doing on the ice is probably drilling a hole for ice thickness. And that means we just want to know how thick the ice is, and that is usually the standard measurement. Before you do anything else on the ice floe, you just drill an ice hole and measure the thickness. So whenever you need a larger hole or anything, you know what you're drilling, because you don't want to figure out after 3 meters of large diameter drilling that you don't have a long enough drill, for example, or that your drill gets broken in certain conditions. So it's really important that you know, first of all, how thick is the ice that you're working on. So how does that work? Well, usually you just attach the 2-inch auger drill, which gives you like a 5 centimeter hole, and you attach that to a battery driven drill and put it on the ice surface and just drill down. So in these videos you can really nicely see how that works. Once you now got the hole, we have a little magic device which we call ice thickness gauge, and it's a little metal thing that we can flap out. It's attached to a tape measure, and we send that one down the hole, and once it is freely in the water underneath the ice, this little metal piece pivots, and when you pull up again, it's stuck against the under ice, and you can read on the tape measure how thick the ice is. Well, you wonder how that gets up. It's very easy. You can actually just pull stronger on it, then this whole thing collapses, and you can just pull it out, and you have measured ice thickness. So it's a very easy thing, and one of our standard tasks that we perform before measuring anything else. Okay, so now you might ask, what are you doing when you really want to drill big holes? So, for example, I am working with robotic vehicles underneath the ice. Some people do diving under the ice. So you need to be able to make quite some big holes into the ice. And then it gets much more difficult. So if we are talking about an ice thickness around just a meter, just under a meter, we are usually using ice saws. We're not using chainsaws. They're just using hand-driven saws to cut through the ice. And that is a very good technique for making rather big holes in a short time. But when the ice gets thicker, that doesn't really work well anymore. You can work around with a few other types of drills, but then the real go-to solution is something we call a hot water drill. And that is basically the same as you might have in your house for showering. So it's just a boiler heating water and then pushing out that water through a drill, well, it's not really a drill, but just through a tube in the front, and then this hot water is melting through the drill. The advantage is it's not very exhausting to do that. The disadvantage is it's first of all rather slow, and the second disadvantage is, well, you can imagine having hot water in very cold temperatures, like if it's -20 outside and you're pumping water around. Water tends to freeze very much, so it can be quite challenging to keep everything fluid and running. But if everything is running, the hot water drill is the last resort for any complicated drilling hole, and then you can easily drill holes through 2-3 meters of ice and make them large enough so that you can deploy equipment through it. So I hope you learned something today about the ice. Hope to see you again here, and thanks very much for watching this, and have a nice day.